All right, let's get started. So today is review day number 1. Thank you. Review day number 1. Today is going to be about concepts, formulas, the strategies, methods, and how we solve various problems. In the next classes, next week, we will talk about, or we will actually go through solutions for particular problems. But today it's just a review of the methods that we should be aware of. I am not going to do review of the calculus stuff because we've just finished doing that, but we'll review all of the other things that we should be aware of for the class. Some quick announcements. Once again, final exam coming up on Monday in 2 weeks, or a week and a half from now, on the 13th. If you are going to come in person, please fill out the form, and you can see the thing for still working. List of people who will be coming in person. This will update. We're getting your information from the form here, and then I have an assistant copying it over to the form over here. So I think there are a few people who we didn't put on yet who just kind of signed up yesterday. So anyways, please do that if you are going to be coming in person. Do that like soon, like today or something, like right now or just after this class. Don't wait until 3 minutes before the test. I have to print off copies. That's not going to go over very well. Right, talked about this already. So pre-midterm review on Tuesday next week and post-midterm review on Thursday next week. Right. Grades, so probably fairly aware, but since you guys are first semester students, just want to make sure this is completely clear. All universities in Korea have this system where there's a limited number of A's and B's available. Everything is graded on a curve. Most of the time, I give out as many A's and B's as I can based on the system. So if you see your grade at the end of the semester and say, well, I got a C, I want a B, or I got a B, I want an A. Moving one person up means moving a different person down, which would not be fair, so that doesn't happen. If you think like all your grades have been released to you so far, the only thing we don't know is the final homework and then like a tiny bit of attendance and the final exam. So if you think there are any problems with the grades so far, tell me now about those things, especially attendance. Attendance gets kind of locked out as soon as the term finishes. So if you wait until you see your final grade and then you say, oh, well, there was an attendance problem, I should be higher, that's way too late and I can't do anything. So if you think there are any problems with your grades, any of the numbers, look at that stuff now. Tell me now about this. I posted a thing about how to check your attendance for each particular day. If there is a problem with your attendance, check the exact dates. Tell me those, and then I will go look for those dates. I'm not going to dig through all the records to find out the days that you were absent. That takes way too long. So you guys can do that for yourself. And final grades are going to be released on December 30th. We do the makeup week, and then we have kind of a grading week and inputs and all that stuff. And then that's when you'll be able to see the total grades. Any questions about that? No, we're good. All right. So let's get to our review. We got lots of slides basically like this. I hope some of you had a chance to look at these in advance. We'll just have the answers blanked out. I'll give you about 20, 30 seconds to think, and then I will ask you what the information is that's missing here. So, well, this one, not that hard. Hopefully we don't need too much time to think about this. If we're going to define a point, what do we need? Coordinates. What do coordinates look like? Okay, so we need an x and a y, just basically two numbers if we're going to define something in 2 dimensions. And on our graph, if we have a grid like this, which directions are positive and which directions are negative? Say them. Yeah. Right. Okay. So up and right are positive directions, and down and left are the negative directions. All right. Next one. Linear equations. We had 2 different ways we could write the slope of a line. What's our symbol and our formula for slope y-intercept? If we have a graph and we want to find the equation, what can we do? If we have an equation and we want to make a graph, what can we do? So take a few seconds to think. Okay, slope intercept form, what does that look like? That's slope. Okay, that's our y equals mx plus b style. What does standard form look like? Ax plus b y equals c. Okay, that's our standard form for a line. Slope is, okay, that is our delta y over delta x. So y2 minus y1, x2 minus x1. What's our symbol for y-intercept? B. This B here. Don't get confused about this. These 2 B's are the same thing. This B is just a totally different thing. We're just reusing the letter. C here is a constant, but it's not the y-intercept. We'll talk about how to get the y-intercept in just a moment with that. All right, if we have a graph and we want to find the equation of that line, what can we do? Okay, so any 2 points is enough to determine, like, to uniquely identify that line. What else could we do? Slope and, okay, so slope and any point, or like our slope intercept form, slope and the y-intercept is our most common one there. All right, and if we want to, if we have an equation and we want to graph it, what can we do? Oh, what points? What 2 points? This is if we have an equation. We have like an equation in one of these 2 forms. We don't have. Okay, so you make points using your table of values. That's the first one. So x and y, and you just choose some random numbers for x, whatever you want. And so, and then use your equation to calculate what would y be. Okay, y is that and that and that. And then you've made points and you put those points on your graph. So that's one of our ways. And the rest are kind of the same. If we've been given points, we can just draw 2 points, connect the line between them, and then the other things as well. So slope and points from our slope intercept form. Start with your y-intercept b, and then just draw the slope through that. And the other one, if we had this standard form, what's the easiest way to graph? Yes, and what is that one? Okay, so the two intercepts. If we remember, if I have this thing and I want to find out what the two intercepts are, then I can just say x-intercept, forget the y term, it's just c divided by a. That's my x-intercept. And then y-intercept, same thing, c divided by b will give me my y-intercept. So that's 2 points that we can get really quickly and easily. So that's, I think, a pretty common way, pretty convenient way to be able to graph a line. Okay, so that's lines and points of intersection. So we could have, for straight lines, we could have 0 or 1 or an infinite number of points of intersection. How do those things happen in terms of slopes? And then what do we call each of them? So take a moment to think. Okay, if there are 0 points of intersection, what do we call it? All right, so parallel lines. And if there are an infinite number, coincidence, the two are just perfectly overlapping and touching everywhere. And then just regular, it's just intersection. Okay, perpendiculars are special case. For perpendicular lines, what is the special thing about them? Okay, so they are meeting at a 90-degree angle. Any other one, it's just something, some angle, we don't know. If the two lines are parallel, what will be true about the slopes? Same slopes, okay. And if the two lines are coincident, what will be true about the slopes? Also the same. They need to be the same in both of these cases. What is true for just a regular type of intersection for slopes? You're thinking of that one. Just not the same. Okay, simple. Okay, but we should be aware of this, like that if they are the same, it's impossible for them to just have a single point of intersection. All right, perpendicular is our special case here. If the first one is a over b, what will the slope of the? Okay, negative b over a. It's the negative reciprocal. We flip it over, change the sign, and that will give us the perpendicular slope. Not so common that we would have two lines and have to identify that they're perpendicular, but like when we did with our linear programming, the shortest possible distance will be a perpendicular line. So often we have to make a perpendicular line, and it's good to know how to do that with slopes. Okay, good. Go on to the next one. So how do we find points of intersection? And if we have two lines like this, how do we find the point of intersection? If we have two equations like this, how do we solve the system of equations? So again, take a moment to think. Got lots of methods. Okay, finding points of intersection, tell me a method. If there's a point of intersection, it won't be 2 points. Set them equal to each other, and then, okay, so that's our substitution method. That's going to be this one here. What else can we do? That's the only method? What else?
Elimination.
Sorry, louder?
Elimination.
Elimination, that's also another algebra method. That's this one here. What else can we do? Algebra is, okay, we can just graph them, right? That will also work. So we can just, if we have the equations, put them on a graph and just look at where they intersect. So that will work. If we want to do our algebra method, substitution, elimination, and the next slide will be a review about how to do those. We can also just test a point. We can just choose some random coordinates and put them into the equations and see if it works for both of them. That's a pretty terrible way to find the point of intersection, but it's an excellent way to test that you do have the correct one. You should be able to solve and sub into both equations. Solving a system of equations, well, it's the exact same thing. So it's the same question, just written and represented in a different way. Yes, there are lots more methods, and matrices is 2 slides from now. Yeah, we'll get there. Right, so straight lines and linear equations are the exact same thing. They just are it's a different way of talking about them. Okay, so let's review substitution and elimination. I've given you some kind of little starting points here. So take a moment and think about how we do these, and then we'll talk about it. Okay, substitution first. What can we do? All right, so one variable in one equation, and then what? Yeah, it could be any one of them, X or Y or Z or Q or F or whatever they are. And then what?
Substitute the variable into the first and then just the second equation.
So let's imagine we have a 3x3 system like this. Do we substitute into just one equation?
No, the first and the second one.
Okay, so we have to substitute into each other equation, not just one of them. So we substitute in, we isolate in one equation and then substitute into all of the other ones. That's how we can reduce our complexity. If we have a 3x3 system, we substitute into all the other equations and we make a 2x2 system. And then we do that whole thing again and we make a 1x1. And that's our repeating process. We keep repeating that until there's just one variable left, and then you can just easily solve for that variable. Okay, and then if we solve for one variable, what do we do? All right, to substitute that back, just you kind of go back up your chain to substitute it back into all of the other equations just one by one. So take your solved one, put it in the 2x2 system, and now you have 2 variables solved. And then the 2 go into the 3x3. You have 3 solved, et cetera, et cetera. If we want to check our solution, what can we do? Okay, into each of the original equations, not just one of them, because it's very possible that you would make a mistake and it would solve one of them, but actually not solve the other ones. So substitute back into each original equation. Okay, elimination, which steps 2, 3, 4 are all the same, but just 0 and 1 might be different. We might need to rearrange in some way. Like in this example up here, we would have to rearrange to do what? What's the goal of rearranging? That's the eliminating part next. Okay. So yeah, you're just lining up your variables basically. So the x's should all be on the same side. The y should be on the same side as each other, and the constants, etc. So you might need to just kind of line everything up and move things from one side to the other. And then to eliminate, we want to eliminate one variable. How do we do that? Okay, same coefficient. We want to make the same coefficient for the variable we're eliminating. How do we make the same coefficient? Okay, so just multiply. Multiply one equation by something or multiply both. And then what? Okay, so add or subtract the whole equation, not just one number or something, but you can add and subtract entire equations to entire other equations. And the rest we just repeat until we're down to one variable. And then we've take our solved variable. Someone has their microphone on who is not actually talking. They're just, all right, thank you. And we sub our solved variable back into the earlier equations, check in each original. So the rest is the same, just how we kind of go about eliminating our first variable is different. Okay, matrices. This was another way to solve these systems, matrix elimination. So if we had this matrix and we this system and we turned it into a matrix, what would it look like? What are the three operations we can do in a matrix and our goals? We have kind of a halfway finished and then a completely finished. What do those things look like? So take a moment and think. Okay, first, what would this look like as a matrix? Okay, A1, B1, C1, D1. So it's just the coefficients and the constant there on the edge. Coefficient, 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 constants, and we see all those here. Just to remind you, in class, we usually didn't write this, but you can always have this kind of vertical line here in the middle, just to represent where the equal signs are, in case you might forget where those are or something. What operations can we do with a matrix? Okay, we can add and subtract any two rows together. And what do we do with the result? We can swap rows. That's sort of a different operation. We add one row to another row, and then where does the result go? Okay, so we are just replacing one of the rows. We replace whichever one is less useful, whichever one we don't want to keep anymore. So when we did just kind of regular elimination, we just make a new equation and we still have the old ones. With matrices, we actually replace one row with our result. If we want to know what the previous version was, we just look back at our earlier matrices to find it. Okay, we can swap rows and one more operation. Right, multiply by a constant, whatever that could be, whatever we want to help us with our elimination. So same operations as, again, regular elimination that we saw earlier. Goals, what does halfway finish look like? Okay, ones on the main diagonal here, zeros in the corner. Okay, so final version is 0, 0, 0, 0, 0, 0, and then 1, 1, 1. What does halfway finish look like then? Okay, and what about this side here? Any number. Okay, usually you're right, it can be any number in the main diagonal. We could do the reducing later. Kind of the standard way, so to speak. If you do have it possible, then you can reduce that to ones. That part doesn't matter so much if those are ones or other numbers, because you can get rid of them later. But this triangle pattern here, where everything is reduced below it, all these zeros here. If we have that, then we have solved for one variable, and we can just very easily go back and find out what the other things are. And the kind of final version is like this, just ones on the main diagonal. And then there's our answer. X is that, Y is that, Z is that. That gives us our result. All right. So matrix elimination, and then we'll come back in a few slides to talk about the other stuff that we did with matrices. Inequalities was next. So how do we graph an inequality? And if we have a system of inequalities, how do we graph that? So take a moment. Okay, so first, how do we graph an inequality? We have something that looks like this down here. How can we graph that? Okay, so pretend it's a line and graph that line. Number one. What's next? So if we are modeling this here, so there's the line. What's next? Okay, so where we have to shade in on one of the sides. So we're shading in above, or we are shading in below. So which area is actually included in the inequality? How do we figure that out? Okay, so what about this? What do we look at in the inequality to find out? Okay, so the sign of the inequality can tell us if it's a greater than, then what does that mean? Above. Okay, so if we have a greater than here, we can shade above. If we have a less than, we can shade below. That's kind of our shortcut. If we want to be really careful, then we can just test any points and just say, well, let's choose this point right here. And I take those coordinates and I substitute them into the inequality. And if it matches, if the inequality is still true for that point, then okay, that point must be included and we are shading everything above. If that point is not true for the inequality, then okay, that point must not be included and then therefore it's the other side. We're shading everything below. So just test any points. All right, and then we have a third thing that we need to do after we have shaded in on one of the sides. What's our final step? Something about the line itself. Right. Do we include the line or not? And how do we figure that out? Okay. So again, about the sign itself, we could just test any point on the line into our inequality, or we can just kind of shortcut and look at the sign here. If it's a greater than or equal, less than or equal, then yes, the line is included. And if it's just greater than or just less than, then the line is not included, and we should redraw it as a dash line like that to show that the line itself is not included. When we did our linear programming stuff, though, those are always greater than or equal. If we have a system of inequalities, what do we do? Okay, so we'll do this whole process for each of them. Let's say here's there and okay, so I've graphed my two inequalities, and then what? Okay, so it's the area where both of them are true, not the area where just one of them is true. It's this area up here. That's the only one that matches both of them. That is our total solution. So it's just visual. We have to just kind of look and see what area matches each of the inequalities at the same time. Okay, good. Linear programming. I'll give you a little more time to think about this one. It's harder. So before we do actual math work, we have three things we need to identify. Then when we're finding our solution, three kind of basic things to look at. And kind of how can we check our work at the end. So take some time to think about it. Okay. I'll give you a few more seconds. All right. What do we need to identify? Okay, so your variables. And in our problems, we always had two-dimensional problems, so maximum 2 variables. That's as far as we were able to get. What else? Okay, so your objective, yeah, your objective, and we make an equation for that objective, an objective function, using these variables. It should be defined in terms of the variables. And what else? Profit, if we're trying to maximize profit, that would be the objective. All right, the constraints. So sorry, there's like a chainsaw or something outside the window. Very loud. Our constraints are our limitations on the problem. Like what is stopping us from having an infinite profit? Well, we only have this much of whatever available, or we have to do it in this much time or whatever. So we express those things as inequalities because we can do this much or less, but we can't go over it. Or this is a minimum of this thing. We can't go under this, but above is fine. Okay, so we've set up the problem. What do we actually do when we are finding our solution? We've already created equations and inequalities. Kind of, we need a lot more detail than that, though. That's like a small part of it, but more broadly, what are we trying to do? What do we need? It looks like something, right? What does that graph look? What's the shape that we make? Okay, so we have a shape. We had a fancy name for it. That was our feasible region. Yeah. So the area of possible solutions, right? That's coming from our constraint inequalities. What values of x and y are just actually possible, are within our limits? And on that shape, what parts of the shape do we care about most? Okay, those corner points, the outer corners of the shape. So outer corners of the feasible region, your best solution will always be one of those corners. So identify the corners, and then we need to find which corner is which one is the best, closest to. Okay, so closest to your objective function. We kind of make our iso whatever lines, iso function lines. We make a bunch of those until we can see which corner is the closest to those. And all right, that's it, right? So we have a line that's close to but not touching our feasible region, and then the corner that's going to be the closest there. That's the thing we care about. Okay, we found the best corner. Then what can we do? Okay, so you just take you find the location of that thing. So here's the actual like value, and then we can substitute that into our objective function. Okay, here's your maximum profit. Here's your minimum cost or minimum time or whatever. If we do want to check our work, we can also take a look at maybe there was another corner that also seemed really close. We can double check that one in our objective, make sure it's not a higher profit, it's not a better point. And if we think we maybe really made some mistakes, we could also take our corner and put it into our constraint inequalities and just show it doesn't go over the limits. It's within the bounds that we had defined for the problem. Okay. All right, so that's linear programming. And we have what? Matrices. Yeah, this is the last one from the pre-midterm material. Okay, so these 4 properties of matrices and then these 4 operations. Try to remember what those things are. Okay, start with the easy ones. Dimensions of a matrix. How do we talk about that? Okay, rows and then columns. We define as rows, then columns. Needs to be this order. Otherwise, when you're trying to figure out stuff about matrix multiplication, you're going to make giant mistakes. Rows, then columns. What does it mean for 2 matrices to be equal? Okay, dimensions are the same. Okay. Yeah. Okay. So same dimensions, same values in all the same positions. So just everything. Everything has to be the same about them. If there's any difference, then they are not equal matrices. What is a null matrix? Okay, it's all 0. Null just means 0 or empty, so that's just all zeros. And this can be any size. What does an identity matrix look like? Okay, one's on the main diagonal. Zeros everywhere else. Not. Okay, so it must be square. Must be a square matrix because we need that for all of our matrix multiplication properties. So one's on the main diagonal, 0 everywhere else, but must be square. That is not flexible. Okay, for operations, what's the transpose of a matrix?
The row becomes column.
Okay, the rows become the columns become the rows. So what's happening, if we look at the result of that, we see it's a diagonal flip. It's not a rotation. I always see that mistake on tests or whatever. It's not a rotation, it's a diagonal flip that's happening. The things that happen with the numbers are different with those two situations. If we want to add and subtract two matrices, okay, so that's our condition. The actual adding, subtracting is pretty easy, just match up the values. But the condition is that they must have the same dimensions. What is scalar multiplication?
Yeah, we need to multiply each position in the row by a single number.
Okay, so we have a constant. And we are multiplying each value in the matrix by a constant. Remember, scalar is just like scale up, scale down, make bigger or smaller. We're not actually changing the structure of it, it's just bigger or smaller. Matrix multiplication is our hard one. So first, what is matrix multiplication? What times what? Okay, so the condition is the second thing, but just how we do it. So it's each row of the first one times each column of the second one. So each row of A times each column of B. And then our condition is no. Yeah. That's easy to get confused, so be careful with that. So the operation is rows of A and columns of B, but the condition is columns of A must be equal to rows of B. So it might seem a little arbitrary, but if you actually try to do the operation and they were not equal, you would find a problem. Like, oh, we try to multiply this, but there's nothing to match it up with, and then you stop your operation. Okay, so how we do it and how we check if we can do it. All right, we had a break even, but we talked about all this with the calculus stuff already, so it's all the same stuff we've been talking about recently. So I'm not going to spend time on that. All right, making good progress. So post-midterm material, again, minus the calculus content. So first, we just talked about exponent rules. We did some practice with this. 5 main rules I said you should learn. And if you remember these, you can remember all the other exponent ones. Take a moment and think about them. Okay, first one. Okay, do we just forget how to say it? Okay. All right, so it's the mth root of A. So m root of A here. So fractional exponent and a root is the same thing. They're just different ways of writing it. If we have a negative exponent, what is that? Okay, 1 over whatever that thing was, in this case, a to the exponent m. If I have the same base multiplied together but different exponents, okay, so we just add the exponents together, m plus n. If I have the same base here but exponent to an exponent, okay, multiply the exponents together, m times n, and same exponent but different bases multiplied. Okay, so we can factor out the exponent. If we have multiplication like this, just factor it out. All right, so these 5 basic exponent rules. There were more that I showed you on those slides when we did like right after the midterm, but these 5, you can hopefully easily derive what the rest of them are. All right. Good, okay. Sequences and series. This is where we have lots and lots of formulas. Okay, well, take a moment, see how much of this you remember, and then we'll talk about it. Sigma notation. Okay, so first, just before we get to the formulas, basic definitions. What is a sequence? Okay, so a list of numbers. Okay, so a list of numbers that follow some kind of pattern. It could be anything. And a series. Those are the types down here. Uh-huh. That's the arithmetic here. So series just means we have a sequence, but instead of commas, we have addition signs. We're adding them all up. So we kind of talked about them the same way, but technically we have a difference there. All right, the 2 big types that we talked about are what you guys are saying. Okay, so our arithmetic and geometric. Arithmetic are based on addition. We add the same thing each time. Geometric are based on multiplication. We are multiplying by the same thing each time. Key terms that we will need for the formulas, A1. Okay, A1 is our first term. AN is, okay, just kind of a general term, whatever n is. D. Okay, so it's our common difference, and this is what we use for the arithmetic. And R is our common ratio, which we use for the geometric sequences and series. Okay, formulas. Okay, good. So this is our general term for an arithmetic sequence or series. So A plus n minus 1 times D. And our partial sum. Uh-huh. Okay, so your first term plus your last term multiplied by n over 2. Yes, so we just take our A, take our AN from here and just substitute that in here, and we get the 2A1 plus n minus 1D. So we just put the 2 together, we can get that other formula. Okay, geometric sequence or series. Okay, so A1 times R to the exponent n minus 1. Remember the minus 1 here in this exponent. Partial sum. Okay, tell me one of them. Okay, so we have the 2, and remember they are the same thing. They're not like, you don't need to use one or the other. You can use whichever one you want. You'll get the same result, just slightly more convenient. This one on the right, it's a bit more convenient if we have our R value that's greater than 1. Absolute value is greater than 1. So A1 times R to the exponent n, then -1. The minus 1 is not inside the exponent in this formula. Important difference. And then all over R over R minus 1. And the other one, it's the same thing, except the R term and the 1 have just kind of switched positions there, but is the same. And this one is just when the absolute value of R is less than 1. This one is kind of more convenient to use. And what about infinite sum? R. Okay, so A1 over 1 minus R. What must be true for us to use this formula? Okay, so the R value must be less than 1. So the absolute value must be less than 1. If the R value is greater than 1, right, the actual infinite sum is just infinity. But if you tried to use this formula in this case, we would get a different result, and you would confuse yourself here. So this infinite sum formula only for geometric, and only for a series, and only when R is less than 1. That's the key part there. All right, this is the, okay, going quickly again. We had 2 types of interest that we talked about, lots of key terms. And then formulas for these as well. I'll give you some time to think, and then we'll talk. It is written there, yes. Okay, so our 2 types, we have simple interest. Simple interest is similar to what kind of thing? Okay, so it's basically an arithmetic series, and compound interest, okay, it's basically a geometric series. Our fancy terms here, P, principal, what does principal mean? Okay, it's your first term. It's your A1. It's your starting value or starting investment or whatever. AT is our. Okay, so our value after T years. So just our kind of final value. Capital I, hello. What is capital I? What part of interest? Okay, the actual dollar value of interest is capital I, and then lowercase I. Okay, the interest rate, the percentage of the percentage that interest is of the original. So, okay, and then T is just our time, almost always in years. All right, and 2 formulas. One plus IT. Okay, so your final value is principal times 1 plus IT. Okay, T is in the exponent for compound interest, and also outside the brackets, not inside the brackets. This version is specifically for yearly compounding. When we talked about interest, I showed that there were also some other formulas for compounding multiple times a year. We just divide the lowercase I over n, and then an n in the exponent as well. And then we had this more complex one for continuous compounding, using E, which E is the thing we haven't really talked about. So this one is specifically for yearly compounding. Your accounting classes will tell you more about that stuff. Okay. Wow. So the other classes, I went 10 minutes over the limit because we needed that much time, and here we are 20 minutes early. That's a 30 minute difference in wow. I don't understand. Happens every time. All right, so in next week we will just be doing practice questions. Like with today's class, I'll have the slides posted in advance, and you can try out those questions in advance, which will help pre-midterm on Tuesday and post-midterm on Thursday. We have a workshop this evening. The first half of I've posted all the questions already. The first half of the workshop will be the total revenue, total cost, profits with our derivatives. So those applications of derivatives. Second half will be about some extra derivative rules, product, quotient, chain rule, which are not a formal part of our class, but if you start doing more calculus stuff, that stuff is needed pretty quickly. So useful to know. If you're interested in that, then that's in the workshop. There is a homework question, and I've posted that already because the previous homework was just the regular stuff with derivatives. We need at least one question about the applications of derivatives to kind of force you to study that stuff and review it. So that's the point of that homework question. It's just one question. It shouldn't take too long, provided you are understanding the concepts. Okay. All right. Any questions you guys want to ask? Yeah. Okay. No. So GPA values, A plus is yeah, 4.5, A is 4.0. There's no A minus, there are no minus whatevers. So next one is just B plus is 3.5 and like that. Yeah, the plus and just the regular are different. Yeah. Standard breakdown is so this is maximum 30%, this is maximum 40%, and this is maximum 30. And then anyone who is ending with an F, this is not included in the 30, 40, 30. So if they're like 50 students, but 5 of them fail, then it means that the number of A's and B's is shrinking a little bit. It's not that big of an effect because there aren't too many people who fail, but it does reduce it. So this is 30, 40, 30 of the people who are passing, the people who pass, not including the F's. That's not a problem. Like, so if they both earned a B plus, then they both get the B plus. Yeah, okay. So if 2 people with the exact same grade, like right on this border line here, then it's very rare for that to happen. Like when I report the grades, it's maybe just as 1 decimal point, but with the way that we're converting, like sometimes there'd be like a 2nd decimal point I can use or something. Or if it were completely equal, everything were equal, then whoever has the higher final exam score. Okay, then midterm. That's very unlikely. I've never run into that case. If that If that had to happen though, then I think it would mean that both people would end up getting the, like this 30% limit, this is a hard limit. I can't go over this. If I try, then the system says, nope, do it again. So I would have to bump both those people down to the lower one. But again, that's a very, I've never had that case happen. Okay, now I see the stress on everyone's faces.
Like I thought like
Okay, so this 30%, this is 40%, and this is at least 30%. These there's no flexibility with this. This is the same for all the classes. Within the class, A plus or A, the system doesn't care which it is. So it could be all 30% just A or all 30% A plus. That's the professor's flexibility choice. Generally speaking, I would give or most professors will kind of prefer the plus, but if for some reason there does happen to be like a really large, I don't know, if the B category ends up being like a really wide group of students, then there might be kind of like a split between them at some point. But generally speaking, the professors will give you the higher of the two that they can.
the final is 40%.
40 or 60 if you do better on the final than on the midterm. Yeah.
Or not.
That was the thing. If that's to give people, because lots of people didn't do super well on the midterm. So that's to give people an extra chance. If your final exam, just basically all final or midterm plus final, whichever gives you individually the higher grade, that's what I'll do. Yeah. For a variety of reasons, primarily about like kind of an anti-cheating measure, there will be, the exam will be long. If you, the midterm, I think there was like 1 or 2 people who actually were able to answer like all of the questions. But there were what, 70 something or 80, 70 something points available, but I reduced the maximum score to 55. So I'll do the same thing. Some of them will just end up being like kind of bonus questions or whatever. But there's going to be lots of questions. The last few are going to be really hard so that everyone is busy the whole time. Definitely, yeah. Question? Yeah. So yeah, I said that before. On the final exam, pre-midterm material is 25%, post-midterm material is 75%. Yeah, that works out. So plus, and when we add that with the midterm, it means the pre-midterm and post-midterm material are overall worth the same amount in the final grade. Other questions?
56. No, not 56. A lot of people draw.
51 currently on the attendance list, and then there may be like 3 or 4 people who like just never shown up or whatever. So passing is about like 48 or so. Yeah.
48?
I don't remember. At every course, there are always a handful of people who like register and just like, I've never seen them once. They've never submitted work. So that's just kind of an automatic attendance failure. There are a handful of those people, not many. So just want to, when I mentioned the 51, that's like for this course in particular, like I know you guys are together in the other classes, but maybe they didn't drop the other classes. There are some upper year students who are retaking, or so it doesn't mean it's the same for your other classes. So, sorry, there's a question. The Fs are not included as the 30, 40, 30. So all, sorry, 20?
That's why you're failing. That's why
Okay. Any other questions? No.
Like, for example, I know
So the review questions that we'll do in our like next week, those should be representative of this. Like it's not, I don't copy questions, I make new questions every time, but degree of difficulty should be representative. And like for all the workshop questions that I recommend or whatever, like you should be going through those practice questions as well, not just the stuff that's been presented in the lecture. If you can answer those like additional workshop recommended questions, then like some of those, the last few of each of those get a bit harder. So if you can do all that stuff, you should be well prepared. Your section is a lot smaller. Section 1, which is not your section, has about 42 people currently, and section 2 currently is 36. This section was originally bigger. I don't know.
your problem.
But you're competing. So you're also competing with fewer people. So it's a percentage. So it does end up being about the same.
This is so unfair.
Okay. If we want to talk more, we can keep talking about it, but I will formally end this now for the sake of everyone online who can't hear the discussion happening in person here. If you do have more questions, hang around and ask, that's fine. Review is coming next week. Look at the review slides before the next classes, try out the questions, that will make things a lot better for you. And then I'll see you maybe in the workshop this evening, and then definitely on Tuesday next week. Goodbye, everyone.